Okay, so 3.7, we're basically going to be doing the same thing as 3.6 in graphing different lines, but these are what we would consider special equations, okay? So special equations of lines, and you're going to figure out what we mean by that. So instead of our conventional y equals mx plus b, there's going to be a couple things here that are a little bit different, okay? So you just got to be a little more familiar with what we're doing in regards to the following examples, okay? So it says the first example is lines with a y-intercept of 0. So in this case, again, we know that y equals mx plus b, knowing that m being our slope, b being our y-intercept, but it says a y-intercept of 0. So you'll notice it says state the slope and y-intercept of the following examples here, okay? So in this case, it kind of looks strange because we have y equals 2x and then nothing else. So typically we have plus b. But what you need to just kind of realize is that it's literally just plus 0. There's nothing there, so it's 0. So in this case, the slope would still be the same, 2 over 3. And your b, or your y-intercept, is 0 because really it's just non-existent in our equation, okay? So if we went to graph this, where do you think we would put our first point? 0, 0, right? Or the origin, because our y-intercept is 0. So it'd be right in the middle would be our first point we'd do, okay? So put that point right there if you could. And then our next step would be to do our rise over run. So what's our rise here? 2. So we go up 2, 1, 2. And what's our run? 1, 2, 3. And we put our second point right there. So like we do every other time we're graphing an equation of a line, what's our next step? Yeah, we just connect those lines. And then we put the arrowheads through the ends, okay, to show that it continues. That's the whole point of doing that. And then what do we need to add? The equation, right? So y equals 2 over 3x. All right. For our next one, what's our slope? -4. And for our sake, what would we want to almost say that it's -4 over Nazir? And then b would be 0. Where's our first point? Origin, or 0, 0. And then it's -4 over 1. So what's our rise? 1, 2, 3, 4. And our run being 1, or positive 1. So our dot would be right there. Get used to counting those down yourself. And then from there, connect those dots. I just missed that bottom one there slightly. And we write our equation, y equals -4x. Okay? So that's the first type of special line. So basically, it's one that we don't have a y-intercept. Well, we do have a y-intercept. The y-intercept is just 0. So it starts at the origin, or our first point is at the origin. Now we're going to go to something called horizontal lines. So we remember that horizontal lines have a slope of 0. So remember, when we were showing you those lines that were connected like so, we knew it had a slope of 0, and it wasn't steep at all. It was flat, so it has a slope of 0. And that horizontal line is represented by an equation of y equals value. Yeah. Yeah. Sorry, for which one? What did we do differently? Really? I did, right? Yeah. Oh, when did I do which question? Which one? All of them? So this should be 3/4, right? That should be -2/3. And then this should be -2. Oh, did I forget one of them? Oh, I'd have to take a peek at that. But no, you should include both of them. It should be the full fraction or whatever the slope is. Okay, we'll revisit that after if there's an issue with that, okay? Sorry? Okay, maybe I messed up. Anyway, we'll continue with that. We'll revisit that in a second, okay? So where were we? A horizontal line is represented by the equation of y equals value. All right, so the y equals value so the y equal the y equal value will show us our horizontal lines. So for the example, it says y equals 7. Well, remember it's y equals mx plus b. And in this case, we don't have mx, right? We don't have that there, but we do have a number, and that's being b. So our slope is 0, but our b is 7. So we would put a point through 7. And since it has no slope, it's a totally horizontal line. And it would look like this. Y equals 7. So for the next one, our slope would be what? 0. And our y-intercept? -5. So we would go to -5. And we'd have that straight horizontal line across with our arrowheads. And it would be y equal to -5. Okay. Okay, our last thing is vertical line. So a vertical line has an undefined slope, like we talked about before. Undefined slope, in which the slope is too steep, it can't be measured by a number of value. We can never tell. So in some way, it has an infinite value. So the vertical line, oddly enough, is represented by an x equals value. And that just shows you where we're starting on our x-axis. So in this case, our slope, if you see something that says like x minus 6, our slope would be undefined. So our slope we do not know. And do we have a y-intercept? No, we don't. So we would just put NA, or not applicable, in this case. But we know it goes through the x-axis at 6. because x is equal to 6. We put a straight up and down line, and we put x equals 6. So using our knowledge of that equation, what do you think we would do with the equation x equals negative 10? What's our slope? Undefined. And our y-intercept? NA, not applicable. We don't know it. But where do we know our point goes? On. Exactly. And we go straight up and down. X equals negative 10.